So we are like, you can start.
Hey everyone, good evening. Hope all of you all are doing good. Okay, so good evening everyone. Welcome back to our day two blockchain bootcamp. I hope all of you all are doing great. So today we are going to cover as part of our day two, like I'm going to show you the agenda, like what are all the topics we are going to cover. So we will be able to go through all of those topics and will gradually be able to move forward. So if there are any questions, yeah, you can feel free to put it over the chat so that I will be able to go through as and when topics are completed. And I hope from Let's Upgrade team, I think this is the chat, which is one single medium, right? Where we will see all the questions, or do we have any other medium where I need to look into? Anybody from Upgrade team? Yeah.
Yeah, so the viewers they can ask the questions in the comments.
Sorry.
1 minute.
Yeah. Because we have a chat box here. If not, I have to open YouTube also and put it aside and have to look into. So let me know. Okay. Yeah. Perfect. So I hope that all of you are equally excited, like how we were in the last session yesterday. Today also we will be able to move forward and get started with our today's topic. Okay, so which is about our day two, and then I'm going to show you the agenda, like what are all the topics we are going to cover, and gradually we will be able to move. Okay. Uh, sure. Let me share my screen now to all of you. Okay, give me a minute. Let me quickly share my screen. Okay, my screen is visible to all of you. So today, as part of the agenda, okay, so today, as part of our agenda, we are going to cover like what exactly is the blockchain technology. Okay, so we are going to understand the introduction to the blockchain transactions and how the transactions in the blockchain world is going to work upon. And we will also get to know how we can create and validate the transactions. What are the cryptographic processes? Yesterday, some of you have asked me, right? Like if you talk about hashing, what are the different security or cryptographic mechanisms we need to follow? That's also something which we will discuss. And we will also get to know what is a smart contract, what are the use cases, like where and all you can use your smart contracts. And then the limitations and the challenges of the blockchain technology. Like what are the different challenges which are available in the blockchain technology, like scalability issue, energy consumption, and how you can address them, we are going to look into, and how we can bring some energy efficiency. Finally, the future and then the conclusion. So overall, if you see today, first we are going to look into the transaction world, then we are going to look into the cryptography world, that where you can protect your blockchain in a much secure way. Then we are going to target the smart contracts world. Then we are going to discuss about what are the limitations and challenges which are being available in the technology. Okay. And then finally, like what are the solutions we have to take care so as to make sure that the challenges we are able to overcome. That's it. And then finally, we'll understand what is the future of the technology and then the conclusion. Okay. Let me see if there is a YouTube also so that there are any questions, I can at least have that open and we can go through it. Okay, awesome. Yeah, it is not possible to hack blockchain because, as many of you rightly mentioned, okay. So if you see here in this case, right, as you could see very clearly, it is something like very difficult to hack the blockchain. The reason being, like 51% of the attackers have to come and try to attack it. It's very difficult, actually. Okay, no problem. Yeah, we'll make it in time. Not a problem. Okay, sure. I don't think so anymore. Any more questions are there? Okay, let me go ahead and get started with our today's session. Meanwhile, in between, I will also come through the YouTube chat and will try to see if there are any questions and we'll try to address it. Okay, and in between, we'll ask some questions. Okay, I'll ask you some questions. You can answer it. In that way, we will make it more engaging. Okay, so no worries. So now, let me first explain to you what are the important concepts which you should know in the blockchain transaction. So when I say blockchain transaction, right, what does this mean? Like how you do a phone pay, GPay, a Paytm transactions, right? In the same way, you can do the transactions even in the blockchain world, but there you are doing the Indian rupee or a dollar or any other currency. But here in the blockchain world, you can basically use your cryptocurrency. Okay, in the blockchain world, when I say blockchain transactions, it is your cryptocurrency basically. Like all your Bitcoin, Litecoin, Ethereum, these are your cryptocurrencies. So you can use your cryptocurrencies and can do the blockchain transactions. That is the first point which you all should basically be aware of. When I say blockchain transaction, what does that exactly mean? It exactly means that your whatever cryptocurrencies, okay, so whatever the cryptocurrencies are being present, all of those cryptocurrencies are nothing but it may be a Bitcoin, your Ethereum, or your Litecoin, any cryptocurrency, whatever transactions you do, they fall under the blockchain transactions. Okay. So now, when you talk about the decentralized transaction, what does this mean? In simple terms, this means that when you send money or data using the blockchain, okay, so you don't need any middleman or you don't need a bank for your transactions to happen. So, for an example, if there are two people, like there is X and there is Y, if there are two people present, they can directly do the transaction without the need of bank in the process. You don't need banking in the system. You can totally eliminate your third party or intermediaries in the process. Okay, directly you can be able to do your transaction without the involvement of anyone in the system. That is decentralized transactions. If X wants to send any transaction to Y, let X send it to Y. And vice versa. Let Y send it to X. But you should not be having anyone as a third party or intermediary in the system whenever you want to do any transaction. Okay, you remember yesterday also we discussed this point, but just letting you know so that you can understand it's a decentralized transactions. Then what is the peer-to-peer transaction? Peer-to-peer means here X is one peer, Y is another peer. For an example, if I want to send some amount of Bitcoins to you, I am one peer and you are another peer. So it should be between peer-to-peer. That means me and you only. There should not be somebody in between coming and saying that, hey, I'm going to control your transaction. That is not the right approach. Okay, so we should not be able to go in that way where we don't want any bank to sit in between whenever we want to do any type of transactions it may be. So that is the point which we all should consider whenever we talk about the decentralized transactions. And immutable. Immutable is a new term which you would have heard about it today, right? Immutable is a new term. But if you know the concept is not new. If you remember yesterday, if you like consider, right, whenever I said a point, whenever you want to add any data into the blockchain, can you be able to change that? Everyone, can you say me? The moment you have added the data into the blockchain, will you be in a position to go ahead and edit that data, or will you be getting a chance to tamper that data? Yes or no? Quickly. Can you be able to do that? Exactly. Okay, exactly. You cannot be able to go ahead and then try to change anything. And that phenomena is called immutable. That phenomena is basically called technically immutable. Immutable ledger means once your transactions or any data in that matter it may be, if it is added into the blockchain network, nobody is allowed to tamper that data, or nobody is allowed to change the data, whatever may be the scenario. That is immutable ledger. Once the data is added into the blockchain, that's it. Nobody can go ahead and can tamper the data, whatever may be the reason. That is the significance of the immutable ledger. So that phenomena is what we call immutable. Okay, nobody can go ahead and edit the data. No one can tamper the data. But can you say me one thing? There is one clause or there is one rule which we have. Okay, if you all remember, there is one clause or there is one rule where you will be able to see that, for an instance, if anybody wants to go ahead and try to change anything, then what is that condition we need to fulfill, everyone? I know nobody can tamper the data, but there is a clause or condition where if they fulfill it, then they can edit or change the data. So what exactly is that? Can anybody be able to say me that? Let me see how many of you can recollect that concept. Okay, definitely you cannot change. But yes, there is one condition or a clause. Let me see how the YouTubers. Yeah. But there is one condition or a clause. What exactly is that? Correct. Absolutely. Yes. Over the YouTube also, I could see, and then even in the Zoom, all of you are 100% correct. Good job, everyone. Keep it up. So, yes, if you want to really go ahead and change the data, right, then definitely you need to have at least 51% approval for you to move forward. So without having 51% approval, right, you are not allowed to move ahead. I mean, if you want to change anything, get majority approval and change it. Okay, if you don't have majority approval, then you cannot be able to do whatever may be the scenario. That is the clarity which you all should basically be able to maintain. Okay, now enhanced trust. What does enhanced trust means? It says blockchain uses a very special methods to ensure that everyone agree on the transaction. Like it's something not like, for an example, you're doing the transaction. Randomly it is taking transaction and adding it. No. So what happens is whatever the transaction you do in the world, okay, any transaction will be distributed in the network. All these transactions is going to be distributed in the network, and among them 51%, okay, that means everyone will validate, and if 51% of them validate and they agree, then only your transaction is going to be successful and it will fall into the blockchain network. So please do not think that I will do some transaction and everything will be accepted. No, that is not the scenario. Okay, basically that's not the scenario. Whenever you are trying to do any transaction, right, you should understand one important point here is you can always go and do your transaction. But whether the transaction, if it is legitimate, if it is the correct one, then it will be approved. If it is not a correct one, then yes, no, you cannot be then able to approve whatever may be the reason. You cannot be able to go ahead and then try to approve. So that is the clarity which you all should be able to maintain. So here we are increasing the trust by ensuring not every transaction is getting accepted. Only legitimate. That means only the correct transactions only we are taking it. Irrelevant, unnecessary transactions are being kept aside altogether. Those are not correct. Who is doing this? So the transaction which is going into the distributed network, they are validating, they are looking into all the transactions, and finally they are approving it. And they are none other than the miners, we call them as. Okay, they are the miners. Miners will look into all your transactions. They are going to validate the transactions and check whether your transaction is an appropriate one or not. If it is yes, it will be falling into the blockchain network. If it is no, then it will not be going into the blockchain network. It is as simple as that. That is how we are enhancing the trust. That is how we are increasing the transparency by ensuring that not everyone can go ahead and then try to attack your data. So this is the overall clarity which we all should basically be able to maintain. Okay. So this is the way in which we all should consider. You have your decentralized transactions. That means you don't need to depend on any third person. You don't need to dependent on any intermediaries. If you are interested to do any transaction, proceed further. Do the transaction in a peer-to-peer way so that nobody will block your transactions at any point of time. Immutable ledger means Once you add your data into the blockchain, you're not allowed to tamper that, provided if you get 51% approval, then yes, you can definitely change it. That is immutable nature. Okay, enhanced trust, we are allowing every transaction to be validated in the network. Until your transaction is not validated, you are not allowed to move forward. Okay, so all the miners who are there in the distributed network will take the responsibility to validate your transactions and then to move forward. That's how the trust is going to be increased or enhanced in this area. So these are all are the points which we should all be able to consider overall here. Okay, so hope that this has given a very good understanding to all of you. So these are the points which we all should consider. So now let's take some questions. Okay, let me see how many of you can answer it. So try to provide me some examples where you can remove intermediaries and you can make your transactions very fast. Can you think of any industries that would benefit the most from this? Okay, again, I'm repeating the question to all of you. What are some examples do you think where we can actually remove the intermediaries, like it may be bank or companies, and then you can make your transaction very quick, very efficient? So can you think of any such industries where the decentralization can play an important role and it can benefit to them? Quickly, anybody over Zoom and as well as in the YouTube? Let's see. Forex, e-commerce. Okay. Okay, consensus mechanism means, say consensus means it is an agreement. Okay, consensus here means it is an agreement. For an example, now we all have a common agreement that we want to come join the session and understand it. Now, who said you? It is your interest. In the same way, now 51% of them have a common agreement that they want to achieve something. That is what we call consensus. Okay, consensus here means very clearly, I would say that all the people who agree for a particular task, that is consensus, which is an agreement. Now, another example is when you play a cards game, right? So what do? You basically play the cards game in such a way that you start the cards with 7 cards or 5 cards or 10 cards. That is a common agreement with which we will start with. Now, you will not say first person will give 1 card, second person will give 2 cards, third person will give 3 cards. Not like that, right? So consensus here is an agreement for us so that we can be able to go ahead and work collectively to validate the transactions so that right transactions are entering into the network. So this is the highest clarity which we should be able to consider. Okay. Digital payment, cloud storage platforms, voting, and here property buying, agricultural products, e-commerce, forex. Awesome. Hey, good job, everyone. Being 50, is it okay? No, it should be 51% only, yes. It should be 51%. It cannot be less than that. 50 also is not permissible. 51% is majority mark. That's it. Okay. Sir, approval of whom? Blockchain is big change and we can get my approval from the miners, Amandi. Approval is specifically from the miners, not from everyone. Miners are the only ones who goes ahead and tries to give the approval, not everybody. Okay. As I said, right, consensus again, just now I explained it. Consensus means it is a common agreement, nothing more than. Okay. Consensus here is nothing but it is a common agreement which we are going to have between all the nodes. Okay. So that means, as I said you, right, all the nodes will have a common agreement that, okay, I will validate. If some of the nodes say, no, I will not validate, that will disturb the system. So consensus is a common agreement which we are going to have it. Okay. Between all the nodes so that they can do whatever the duty which is provided to. Okay. So now smart contract development is not today, Nanda. Okay. That will be taken care of. Probably, I think that's not scheduled in the session. This is only to give a high level overview. Okay. So what if we attack on their private key? See, there are different approaches here. Private keys, first thing is you can store that in the wallet. Now, if the wallet is compromised, your private key will be gone. Very straightforward. Second thing is you can store the private key in a hardware wallet. Okay, you can always be able to store your private keys in a hardware wallet. Hardware wallet is a wallet which is like your pen drive or which is like your hard disk. Okay, where until you do not connect to your system, nobody knows what is present inside. So you can make it more secure by using a hardware wallet, okay, where you can store your private keys, where it will not be connected to internet. If it is not connected to internet, until you reveal your private key, nobody else can come and try to attack. So hardware wallet is the most safest. Apart from that, people also try to save the private keys in some of the wallets. But again, if the wallet is really trustworthy and if you really believe it has a good track record, then you can store the private keys even in that wallet also. But do not try to have a very low sized wallet or which doesn't have a credibility, right? Do not go for those wallets because your again keys may get compromised. Okay, this is the approach which you need to follow. Okay, so I have answered all the questions and thank you all for participating and trying to provide the answers like where and all we can use decentralization. And I absolutely agree with all of you that those are all are very good points where you can remove a lot of intermediaries and can make sure that the process is more resilient enough. Okay, so now let me say, as you all answered, right? Immutable ledger means like, once you add the data, you cannot tamper it. But again, remember one thing, there is a clause. If 51% of the people agree to it, yes, then you can be able to go ahead and can tamper the data or can edit the data. Okay, so that is a good clarity which you all should basically be able to understand. So now taking you to the next part over here. Okay, so now moving to the next one. So as I already said, what is happening is whenever you are trying to do any transaction in the network, how it works? Transaction initiation. Transaction initiation means what? As I said you, right? There are two persons. Imagine there are two persons, X and Y. X wants to initiate a transaction to Y. That is a transaction initiation. Okay, so what will happen? X and Y. So X is going to have public key and private key. And then Y is going to have your public key and then your private key. Okay. So now private key should not be shared with anybody. Public key is like your account number, which you can share with anyone. So X will ask to Y, give me your public key so that I can send the money to you. Okay. So now let me say X wants to send 2 Bitcoins to Y. So to do that, X is saying to Y, you please share me the public key of yours. So the public key of the Y will be shared to X, like basically take it like a bank account transaction. Now I want to send some amount of money to you. Can I send it directly by just using your name? Obviously, like you, there are thousands of people. Now, how can I identify you? So you say, hey, no problem. I have a bank account. I'll give you an account number. You send the money to that account. That makes sense. In the same way, if X wants to transfer some amount of money to Y, X will say to Y, please give me the public. So that we will take that public key and we'll try to do the transfer of money, whatever we wanted. This is the clarity we all have to understand. Okay, so private key should not be shared with anyone. Have you ever shared your net banking password with anyone? Obviously, no. So same here. X and Y, they will have their own private key and you should not be able to ask that private key, whatever may be the scenario. So this is the clarity which you should be knowing. That is how transaction will get initiated. Okay, cryptographic keys means do not get confused. Cryptographic keys are your public and private key. This is what we call cryptographic keys are. Cryptographic keys are nothing but it is your public and private key. So that is what we call here as our cryptographic keys. So this is how the transaction will initiate. So whenever you want to do a transaction, first you're going to ask, hey, please provide me your public key so that I'll get to know your public key and then I'll try to transfer the money, whatever you. So then what is happening here? Your transactions are now getting broadcasted. Okay. After the transaction is started, now once X initiates the transaction to Y, now that transaction is going to be started here, where it will be broadcasted to all the nodes in the network. Whatever nodes are being available in the network, right? So to all the nodes, the data will be distributed. Okay, so these nodes are I mean, the checkpoint. These nodes are basically like a checkpoint where it will be validating whatever the transaction which X and Y is doing. Like this, there are so many nodes. Imagine there are 100 nodes. Now, all the 100 nodes will get the data, that the transaction data, it will be broadcasted to them. And among them, at least if 51, that is 51% majority, if all of them agree, then it will move forward. So verification process is where you see that all of these nodes will work together to make sure that if the transaction is correct or they will use some algorithms behind, and they will make sure that whether if the transaction is a genuine one or whether if it is not. Okay, that will be considered. If everything is good, the transaction is added into the blockchain network. If it is not good, then you will see that your transaction will not be added. So this is the process which we all need to follow. So overall, if you see in this case, first your transaction is getting initiated, where you're initiating the transaction by asking the public key of the other user. Then you're broadcasting the transaction. That means you're distributing the transaction to all the nodes which are there in the network. Then all of these nodes are validating your transaction, whether if it is a genuine one or not. And if 51% of them agree that yes, it is a genuine transaction, then that transaction will be added into the blockchain network. Otherwise, it will be rejected, and you will get a message that your transaction is rejected with the reason that why it got rejected. So this is the clarity we all have to mention overall. I mean, the same thing what we discussed, just I want to make it very clear so that you don't have any specific confusions in this concept overall. Are we all good here? Shall we proceed move? Okay, is simple example, consensus mechanism. Simple example, as I said you, right? Play like cards game. Now, for an example, you're playing a cards game. Now, what happens? There are 4 people who are playing cards game. Now, how it will happen? Now, you will not say first person I'll give 1 card, second person 2 cards, third person 3 cards, fourth person 4 cards. You will never do like that. Now, there are 4 people. You all have a common agreement. That is a consensus saying that, okay, let's start the game with 5 cards. Let's start the game with 7 cards. Let's start the game with 9 cards. That is a common agreement between all the 4 people. And you will be distributing the card to all the people in the same way. Like you will not show partiality and say that, hey, for the first person, I'll give only 1 card. For the second person, only I'll 2 cards. That is never going to happen. So consensus means having a common agreement that where you all are going to consider those points. Like you are all going to have same cards so that you all have that common agreement. In the same way, nodes in the network will also have a common agreement so that they will do the validation appropriately rather than saying that, hey, I will not validate. Some nodes will say, I will validate. Then there is no common agreement between them only. Then what are they going to validate others? That's not going to make a valid point, right? That is the main significance to it. Okay. Is memo public key? Memo means like what exactly? I mean, yeah, anything which is open to the outside world is a public key. Anything which is confidential, which you don't want to share it with anyone, is a private. Okay. So one more time, I'm just trying to repeat it to all of you. Whenever you want to initiate a transaction, okay, first you need to ask the public key of the other person, like how you ask an account number of others, right? So then you initiate your transaction. After you initiate your transaction, right, then automatically this transaction will be broadcasted to all the people who are there in the network. Imagine you are sending a broadcast WhatsApp message. What will happen? That broadcast WhatsApp message will go to the people who are there, whom you have selected. In the same way, the transaction will be broadcasted to all the nodes which are there in the network. Now, they will validate your transaction if your transaction is a genuine one or not. And at least if majority, 51% of them approve, then your transaction will go and fall into your blockchain network. It's as simple as that. If your transaction is not genuine, then it will not fall into the blockchain network. They will reject your transaction and will let you know the reason that why the transaction actually got rejected. This is the entire process. Okay, which I was able to explain to all of you. Hope you can take a note here. Okay. Let me see over the YouTube. Okay. Attendance and all, yeah, you can just take care of that part. Like I think the team is going to let you know for that. Okay. Upgrade team. Yeah, but as of now, I don't see any questions. Good. Awesome. Fine. So then let me move further to the next part over here. Like what is the next thing we'll be able to go ahead and understand it. Okay. So now coming to cryptographic security. Now, what exactly is a cryptographic security? See, it's a very simple thing. Security, see, without security, you cannot do anything. It's as simple as that, right? Because today, blockchain is securing your data. That's what we explained or we understood yesterday. When you talk about blockchain, the very purpose of having blockchain is to make sure that we are securing the data to the maximum extent, right? That is what ideally we go ahead and then try to do it. So now, if you see here hashing, what is hashing? Yesterday, many people asked me, right? Hashing, think of this like a fingerprint. How you have your fingerprint as a unique identity for yourself, every block is going to have its own identity, which we call it as the hash. So in a very simple way, hashing is that only. That's it. Now, what will happen is, for an example, there is a block. In this block, I write blockchain. Okay. And for this blockchain, there is a hash present. Okay. Now, for an example, if somebody comes and changes the data saying blockchain is awesome. Okay. That means is awesome got added extra. Then the moment you add even a single data to it, right, your hash will automatically get changed. If you come and add even a single thing to it, right, then automatically you are going to see that your hash is going to be totally changed. So whatever hash is there, that is fixed. Whatever hash is there, that is fixed. Now, if you come and add something on top of it again, whatever the data you had already, if you come and try to add something on top of it again, right, like is awesome, I added, automatically your hash will again change from there. You will see that automatically your hash will again change. As and when you add your data, your hash will change. If your data is locked, your hash is locked. If you keep on adding the data, as per your data, your hash will also keep on changing. Now, what is hash? Okay, I know hash is a fingerprint, which is like how I have a digital identity in the same way. Okay, like you will see that hash is nothing but it is a digital identity for a particular block. Awesome. That's all good. Now we all got to know that, okay, based on your data, your hash is being present. Now, if somebody adds some additional data on top of it, again, your hash will change. Now, what is hash? Hash is nothing but it is an encryption. Okay, so now what happens is I'll say, okay, blockchain is like, let us say blockchain is great. Now, if I put this content like this, everyone can read because you all know English, you all can understand it, you all know very well. So you can understand and you can read it on your own in a very pretty easier way. Now, if I go and convert this into some junk characters, like say A, 2, 3, G, B, C, A, 1, 2, like something like this. Now, if I ask you to go through it, I mean, you'll go through it, you'll definitely read it out, but you don't know. I mean, what is the meaning behind it? What is the logic behind it? Or what is that which is written here? I'm not able to understand. It is what definitely we will try to think. That is encryption. Okay, hashing is a process of encryption. So what we want to do is whatever the data which is available in the block, we do not want at any cost that data to be present to the outside. So whatever data you have, even if anybody looks into the data should be like a junk characters, the one which I'm highlighting. It should be like a junk characters where no one can see the exact data, even if they're able to see, but they should only see the junk characters, which is nothing but encryption. Encryption is nothing but your hashing mechanism. So here we are making it very clear. Hash is nothing but your data is encrypted. Encrypted means it will be like a junk characters like this, so that nobody can exactly see the information whatever you want. So either they have to decrypt it or otherwise they will never know what is being communicated. It's as simple as that. That is your encryption technique, where you're increasing transparency by ensuring that no third person can see the information of whatever you are trying to provide, which is actually one of the best steps, I would say. That's how encryption plays a very important role, where you are trying to protect your data by making it more secure and transparent, by making it more like adding a junk characters and by not allowing anybody to read that data directly. That is a very good process, I would say, as an encryption technique. Then you have your real life analogy. I mean, in the real life, how it works. Like imagine you lock your email with a password, right? Imagine you lock your email with a password. Now you can unlock it easily. Why? Because you know your password. Now imagine if you forget your password. It is going to make your life very complicated because you cannot unlock your mail. Either you have to say forgot password, again retrieve it, again create a new password, and you have to move ahead. But imagine for a second, as long as you remember the password, awesome. You don't have any concern. But the moment you forget your password, right, it is going to be very much impossible for you to go and hack it without the password. So password is very important. Now, in the same way, when you're encrypting the data, if you really want to decrypt it, you need your private key. Okay, and without private key, you cannot decrypt it. So you are making life tougher for the others. For an example, I am sending content to you, blockchain is great. So you have the private key with you. So you can decrypt and can see the information. But if other person comes, right, like third person come and want to look into it, they will not be able to read any information here. Nothing will be visible to them. Okay, only thing visible is the junk characters. And they don't have the private key because private key, we will never share it with anyone. But yeah, if you may ask me, if my private key is compromised, then yes, they will look into the data. It is simply like your email password is compromised. You have shared to somebody or somebody else has stolen your password. Then obviously that person can enter into your account and can see the Gmail, right? Same approach here also. As long as you are protecting your private key, you are the winner. The moment your private key is being revealed to the outside world, then people will take the control of your operation. So that is the clarity you all have to maintain. So whenever you talk about the cryptographic security, it first starts with hashing process, where it is going to make sure that whatever the data is available in blockchain, it's going to encrypt it like a junk characters in this way, so that no third person can see the information of whatever you are actually trying to communicate. And again, as I said, hash is always fixed for the fixed data. Now, if you come and try to change your data, automatically your hash will also keep changing. Okay, and the real life analogy, I said you that how you have your email, right? Like you have a password and the email. In the same way, even in the real life also, you are going to see as long as you are protecting your password, you're safe. The moment your password is compromised or somebody has taken away, that means you are lost. So in the same way, here also, you have to take care of your private key. If your private key is in your control, then you can do whatever you. The moment your private key is lost, that's it. People will start automatically taking the control of your wallet, or it may be your data, whatever you are trying to communicate. So this is the clarity which we all should basically be able to know with regards to the security in the blockchain. Any questions on this before I take you on to the next one? Let me see from the YouTube. Any specific questions from anyone? What are the attributes that the miner will look into order to validate the transaction? So whether you have enough balance or not. Okay, whether let me say you have 5 bitcoins, but you're sending 10 bitcoins. Is it going to be possible? No, right? So definitely either you have to send 5 or less than that. You cannot send more than that. So those are the attributes which they are going to check majorly. And whether you have a valid public key or not, whether you are the right user or not, whether have you done any previous transactions or not. So all of these things will be taken care of. Okay. How the hashing mechanism ensures data integrity and security in blockchain. So yes, I hope you got it right now. Okay, so and at the back end, it uses an algorithm called as the SHA-256 algorithm. Now, these encryption or hashes are getting generated with the help of this SHA-256 algorithm, okay, which we call it as the secure hash algorithm 256 bit. Okay, if you want to know, this is the algorithm mechanism which has been running behind the hood to make sure that all of these encryptions and security and integrity it is trying to preserve, because it is very difficult to break this algorithm. Okay. So that is the reason why nobody can come and try to attack, which is actually giving a good amount of security. Okay. I think here I have resolved it. Let me go to the Zoom and see. Okay, what if just like an email password, this key is also lost, and is there the alternative? Okay, very good question. So no, we have to be very careful with our private keys. Okay, once it is lost, it is forever lost. It's not like our email where you forget a password and you say forgot password and then you easily try to recover it, right? But here that's not the scenario. Here it is not allowed like that. You have to take care of your private key. The moment your private key is lost, that means you're done. Okay, you cannot recover that key. That is the reason, please be very careful with your private key. Private key, okay, let me lose one private key, then again, next I will create one more private key. If you are in that impression, that's a wrong thing, okay? You are not allowed to have another private key, whatever may be the scenario. Only once the private key will be there, you have to protect it as much as you can. The moment you lose your private key, you're done with it. You don't have any other option, okay? So that is the clarity you all have to maintain. Okay, hope we are clear with this slide. I have covered all the questions the people who have all have asked it. So let me go ahead now to the next concept over here. That is your smart contracts. Okay. Now, talking about smart contracts, it's a very simple and straightforward topic. I mean, you don't need to think through a lot over here. It's a very simple and straightforward concept. So let me explain to you what it is. See, smart contract is basically like an agreement which is written directly into a computer code. So for this, we use a Solidity programming language. I mean, you don't need to go into the details of it, but just I'm giving a high level overview. Okay, if you really want to write a smart contract, you can write it directly in the computer code using Solidity. So once it's on the blockchain, right, it runs automatically. I mean, it doesn't need anyone to manage or enforce it. Everything happens as per the program, whatever you have written. Whatever the program you have written, right, everything is going to work as per the program, whatever you have been able to write it. That is the significance of the Solidity. Okay. So definition of smart contract is it is a self-executing contract. That means, for an example, the people who know programming, you write the logic in the program. So as per that, your program will run. Again, you don't need to bother about it. Same thing. Smart contracts are nothing but you can write a computer program using Solidity programming language. And based on whatever the logic you have written in the code, accordingly the program will run. And it becomes self-executed where it will automatically be able to do the things for you so that you don't need to bother about it much. So that is the clarity you all have to maintain here. Okay. So overall, if you see in this scenario, right, one more thing which I just want to highlight here is these smart contracts at the end of the day will be deployed on blockchain. Okay. So whatever smart contracts are there, that is going to be deployed on blockchain. And you know, once a smart contract is there in blockchain, it is immutable. That means nobody can come and tamper your data. Nobody can change anything in the smart contract. The smart contract will be distributed to all the nodes in the network who are available. So we are ensuring that nobody can take the control of the blockchain at the end of the day. So the smart contract, it's not like, okay, you develop smart contract and you're done with the job. No, your smart contract at the end of the day is taken care and it is added into the blockchain layer so that nobody can take away the data from you. And nobody can tamper the data also. That is the definition of a smart contract. Okay, it is a self-executing contract based on whatever Solidity logic you write. Accordingly, it is going to behave and it is self-executed. It is going to know how to work based on logic, whatever you have written. If your logic is right, it will work right. If your logic is wrong, it will not work in a right way. And ultimately, your smart contract is getting deployed on the blockchain platform. Okay, so that nobody can basically be able to tamper the data. Okay, so that's the clarity you all have to understand. Now, autonomous execution. By this time, you already know autonomous execution means these contracts are going to execute and run on their own when certain conditions are met as per the logic, whatever you have written. Say they don't need any person to check or push a button or like we don't need any manual things over here. Everything is done automatically where you're going to make the things faster and more efficient. I mean, you don't need to be dependent on anyone specifically for you to handle the tasks. Everything is been done automatically on its own. So you don't need to bother about the process. It will be able to go ahead, run the logic in whatever way it want, and it will be able to move forward. That is autonomous execution. You don't need a third party, you don't need an intermediary, you don't need an external person to come and check all the things over here. That's not needed. Okay. And if you want to take a real life example, imagine like you have a vending machine, right? So you have a vending machine, like when you put in the right amount of money, the machine will automatically give you either a cool drink or a snack. Now, this machine doesn't need someone to hand you over the things like snack or a cool drink. It works automatically. Similar to that, how your smart contracts also function. Right? In airport or maybe in the bus stations, you see that there is a big vending machine where you put the money and it is going to give you a change and as well as the product. It may be a cool drink or it may be a snack. Now, there is no person sitting there and saying that, okay, you pay me money and I will give you. No, the machine itself is so smart that it is working on behalf of you. There is no third person needed for it. Same like that, your smart contract is also going to work. Whatever the logic you have written, as per that logic, your smart contract is going to work. It's as simple as that. It's not going to ask you any additional questions apart from. And you don't need anyone to handle this. Once the logic is written, once your smart contract is deployed into the blockchain platform, automatically everything is going to work on its own. I mean, you don't need anything specific again to be called out over here. It can just be able to go ahead and can handle the things in whatever way it can be. That's how simply the process can be worked upon. Okay. Hope that this is clear to all of you. So let me see if there are any questions from anyone. So, but again, let me first understand what it is. Then I will ask you some questions. Let me see how many of you can answer that. Okay. But before that, let me understand if there are any specific questions from you. For implementing cryptographic algorithms, do we need to have a grip of DSA? Not exactly. Okay, not exactly. Because in blockchain, right, we don't need to go into the cryptography mechanism in a very detailed way. Okay, it's not exactly we need it. Just some idea of DSA is sufficient, but not in-depth knowledge about it. Okay, what is this contract for about what exactly? So what is a contract for about what? See, contract is nothing but it's like a program. See, generally, if you know about Java and all, right, we say class. Okay, basically, we say class and all, and then we write it. Here we call it as a contract. Contract is nothing but it's a program only. Okay, do not confuse with the term contract means what? Smart contracts, how you write a program in C, C++, Java by writing a class and all, right? Same way, instead of writing a class here, you say contract. Contract and the contract name. So, contract is nothing but it is a program which is going to run as per the logic, whatever you write. So automatically it will execute on its own. You don't need any third person to handle that. And this smart contract, whatever you're developing using Solidity is getting deployed on blockchain platform so that no third person can come and try to attack the data or no one can tamper the data. That is the only thing. So do not get confused with the term smart contract. It is basically smart contract here is nothing but it is your program and the program is written using Solidity. Not only Solidity, you can use other programming languages also, like you can use Solidity is the most famous language, okay? You can use Python, you can use Go language, you can use Java and can be able to write the programs, okay? So you can also develop your programs using existing programming languages, or else you can use Solidity, which is the most preferred language, or which is the most used language for developing a smart contracts. Okay, let me see in the YouTube. Yeah, awesome. There are no questions over here. Good. Is it clear for everyone? Any questions before I take you on to the next, next set of questions which I want you to ask so that you can all answer it? Any more questions from anyone, either from the Zoom or from the YouTube? Okay, I don't see here from YouTube. I think it looks great here. And in the Zoom, I think there were some questions. I think I was able to answer that. Perfect. So you all got it right? The questions which were being asked. I hope you all are clear, or any further information is needed before I go ahead and ask the questions to you all. Okay, perfect, awesome. So then, yeah, let's go ahead. So say me one thing. As we got to know this, can you think of everyday situation where a smart contract could replace the human involvement, just like how we discussed about the vending machine, right? Can you give me some more examples where you think that, like every other day situation where you can have a smart contract which could totally replace all the humans who are being there, just like how the vending machine is working, right? Can we use smart contracts at any other places where you think that it is going to be beneficial for all of us, where we don't need any third person or intermediate or any manual work to be involved? Please, everyone, could you go ahead and answer it? Okay, very good. ATM, petrol pumps, online shipments, awesome. Best recommended language for blockchain is Solidity. Okay. Let me see over the YouTube. So come on, everyone. So what are the things? Okay, so can you just say me like where and all we can use smart contracts so that it can work automatically on its own? Okay, without having any third person. Okay, bank, which is a good thing. Good. Any other examples from anyone which you would like to share? Okay, voting system, awesome. Where we do not want any third person to come in and try to break it. College, awesome, good, nice, good points. Any other points from anyone before I explain the answers to y'all? Attendance, toll scanner, okay. Highway speed detection, good. Agriculture, vegetable seller, okay, awesome. Ticketing system, okay, perfect, good. TEFI, decentralized finance, traffic camera, okay, perfect. Great job, everyone. Good. Keep it up. Keep learning like this. Theater, good. So now I'm gonna go ahead and explain to y'all. Okay, where and all we can be able to use. Okay, where and all we can be able to use it. Same as like what you all have highlighted it. All of you were spot on. You have done a great job by giving the answers. So now in the same way, I will go ahead and put my thoughts. Like where and all we can use apart from whatever y'all have highlighted it. So let's have a look into it. Okay, first. Financial applications, the people who all have answered related to finance, right? Banking, okay, or insurance, lending machine. So all of these are financial applications. So here you can use your smart contracts to automate all your payment and financial transactions. So this will make your process very faster. It will reduce the risk of any fraud, and it is also going to build the trust because the contracts will definitely follow the logic, right? The contracts are definitely going to follow the logic. So as the contracts are going to follow the logic, so you can use it in financial applications by removing a lot of intermediaries in the process who have been there. Everything becomes automated. Like let me say there is a you are taking the loan from the bank. EMI should monthly be deducted. Now smart contract itself should take the money and it should credit it into the bank account. So financial applications has a wider scope for the smart contracts where you can be able to implement it in a much efficient way, where things will become automated and you don't need any third person or intermediary to handle the things. Okay. Then you have another one called as the your supply chain management. Your supply chain management means again in supply chains, right? What happens? Your smart contracts can track each and every step, starting from manufacturer, retailer, wholesaler, consumer. Every step smart contract can track and it can store the data into the blockchain so that nobody can tamper the data. Okay, whenever you want to backtrace, whenever you want to go back and have a look into the information, right? Then definitely supply chain management plays an important role here, where you can always go back and try to trace and identify if anybody is doing any manipulation, if anybody is trying to tamper the data, if they are trying to play around with it, then you can always be able to detect it. For that, supply chain management plays as an important, okay, where you can always create an accountability and you can see the information in a better way. And some of you have also highlighted about property, real estate and all. Okay. So now when you say property, whenever you buy or sell the property smart contracts, right? It will make sure that ownership changes, right? When you're selling or like transferring, right? Ownership will change. So now, whenever there is a ownership change, right, some manipulation also will occur. So what we want to do is we want to ensure that we create a smart contract where it is going to capture every details without the needing of any middleman like a lawyer or a bank to oversee it. We don't want that. Let's go and try to handle the things on our own automatically, where smart contract itself will be able to detect from whom to whom the land documents have been transferred, how much money did you pay. All of these details will be captured by smart contract and it will be present in the blockchain. And you know, inside the blockchain, nobody can come and tamper the data provided if you have majority. So your data is very safe and secure and no one can tamper the data. In that way also you can create your smart contract and can handle all your property transactions, whatever you. So this is another way which you can be able to handle. And then you have your supply chain management, where you can, again, as I said, you can track all your records and you can see whether everything is transparent, appropriate or not. In the financial applications, you can make all your transactions automated so that you don't need to depend on any single person to do the task for you. In short, smart contract itself will be able to do everything for you. And the best thing here is smart contract, you wherever you implement it, smart contract at the end of the day is tracking everything in a very secure way in the blockchain so that nobody can be able to tamper the data. So at the end of the day, whatever the data you are seeing, right, that is a single source of truth. That is the absolute truth which you're seeing. Nobody is having the right to go ahead and tamper the data, and that's the beauty of it. That is how you can implement your smart contracts in different areas or sectors which are being available for us. So this is the clarity which you all should basically be aware of. Okay. So any questions before I take you to the challenges of the blockchain technology? Before I make you understand the challenges of the blockchain technology which are available right now, any questions? Let me check it out. Okay. No questions over here. Nice. Let me see here. Is there any other language other than Solidity? Just to explain, right? Not only Solidity, not only Solidity, apart from Solidity, you also have like a Go language, Python, and Java also you can implement. Okay. Is blockchain in first place regarding security compared to all other technologies existing? Exactly, that is correct. Blockchain is meant to secure the data in whatever way it may be and in whichever sector it may be present. Okay, so that's the clarity we all have to understand. In YouTube, I see everyone says no. Okay, perfect. Awesome. Great. Then let me explain to you the challenges of the blockchain technology which are currently being present. So one is the scalability concern. Another one is the energy footprint. Third one is the adoption barriers. Okay, let's see that in a detailed way, right? So coming to scalability issues. So what is the scalability issue? Scalability issue means, for an example, transaction congestion. What does this mean? It says when too many people use the blockchain at the same time, right, it can slow down. Imagine just like how traffic jams happen, right, during the rush hour. This makes transaction take longer to process. Like when you have a heavy traffic on the road, your vehicles will not move. And in return, that is going to again take a lot of time. So, in the same way, when many people are doing a lot of transactions in the blockchain, that may create a congestion issue. Now, you may ask me, what is the solution for it? That I will explain in a while. But right now, we are only understanding the challenges which are available. How to get a solution? What is the approach we have to follow? That I will explain once you get to know all the challenges. Okay, that is the transaction congestion. When there are too many people who are implementing blockchain or who are utilizing the blockchain, then that's going to utilize a lot of time, and that in return will make it very difficult. And coming to network efficiency, see, network efficiency here very clearly says to make blockchain really work better, right, we need to find out the right balance by keeping it decentralized. That means nobody can control it, and at the same time you also make it very fast, because this is very important. Now you'll say we are decentralized. Great. That means you're not giving control to any single person. Awesome. But just because you're saying decentralized and you're saying that I will take for your transaction to confirm 1 hour or 2 hours, 10 hours, then definitely you'll say, why would I go and use it? Okay, let me go with a centralized and let me confirm a transaction within seconds. Why should I wait for so much time? So, right, network efficiency means at times it may create a problem where if the network is too busy and if it is decentralized and you have to wait until 51% approve and give you that validation, at times it takes some time, within seconds only. But still, there is a problem with the network efficiency also, where you need to wait for at least for a little time to make sure that your transaction is confirmed, as it is decentralized. As it is decentralized, there's no single central authority. Instead, you're distributing the transaction across all the people in the network or across all the nodes in the network, waiting for majority approval to proceed further. At times, that can also create a problem. Okay. And coming to solutions, okay, potential solutions are nothing but there are ways in which you can do this. Like you can be able to use a concept called as the sharding. Okay. Now, sharding means you can split your work into multiple parts. Okay, you can do it in a multiple parts, right? Rather than doing, see, now transactions are there. Instead of clubbing all the transactions, take first 5 transactions at a time, complete it. Then you take another 5. So if you take all 100 transactions and if you are not able to settle even a single transaction, then that will lead to congestion. So to get rid of congestion, do sharding. Sharding says that, hey, you split your work and do it. Split your work and complete it. Rather than taking everything and not making anything successful, split it, break it into multiple pieces, and then you proceed and further do it. Rather than taking everything at one go and then trying to break the entire flow, which is not a good practice. Do it in a limited way, break the flow, try to do it in such a way that everyone is getting an opportunity and complete it, rather than making everything haphazard, no clarity, and that's going to break the entire system. That can be one of the potential solution which we can think through by reducing the scalability issue. What is another issue? One is scalability issue. Another issue is the energy consumption. The energy consumption is so high of the blockchain platform that at times it really becomes very difficult. Like for an example, if you see the impact on the resources, okay, if you see here, impact on resources. So this is running blockchain operations, right? Especially like mining, which uses like a lot of electricity. This raises concern because it consumes a huge amount of resources, which could actually lead to issues like energy shortage. Imagine a Bitcoin mining takes the energy of almost a country like Ireland. That much amount of energy it will consume, which is a problem because right now the world is not having a lot of like what we call energy. Okay, environmental concerns are so much. And on top of that, you do something like this, and where you're consuming away the energy, whatever is still pending, and that's something which you're impacting the environment. So we don't want to have like those type of things where you will consume a lot of energy and impacting the environment. That is one challenge which we have. Okay. So if you would see about the real life analogy, right? So imagine thousands of computers are running at the same time. All of them are working hard. This is what happens with the Bitcoin mining. It uses an enormous amount of energy, which is not good for the environment. Imagine in a room, you're using 1,000 computers. That means you're using an excessive energy where the heat will be so much that sometimes you need to put a lot of ACs to cover that, or otherwise there will be a blast occurring. And on top of that, you're taking away the energy from the environment and you're actually utilizing it in a very wrong way, which can actually create one of the biggest problem. See now, previously everyone used this actually had this problem, but right now only Bitcoin is having this problem. Remaining cryptocurrencies like Ethereum, Litecoin, they don't have this problem right now. They got rid of it. But today, yes, Bitcoin still have this problem where it consumes a lots of energy, and that can create a big problem. Okay, so to solve this problem, what we have to do? What is a solution to solve this? To solve this problem, bring some new blockchain technologies which are being developed using less energy and are more environment friendly. These platforms are going to reduce the energy which is being used by making the process really more efficient. So we need to think through, we have to think in such a way that where we are bringing an approach, where we are bringing an alternative, where everything is environment friendly. It should not burn the environment. It should instead protect the environment. It should instead be able to efficiently handle the environment appropriately. That is how you have to come up with a solution. So currently you should know, yeah, the energy consumption is very high. It's almost equal to Ireland. Imagine, okay. So you are depleting or you are taking away a lot of energy which is available in the environment, which is not a good practice. As I said you, right, imagine there are thousands of computers in one room. That means they are taking away a lot of energy. It is not a good approach. So only solution is come up with more eco-friendly or innovative approach where we can use less energy and that we can make it more environment friendly, and it can be implemented in such a way where we can make the process very efficient. But yeah, this is one of the another challenge. Apart from scalability, we have energy consumption as another challenge. Now, before I explain you the solutions in a very detailed way for scalability and energy consumption, any questions on the scalability and energy consumption? Only challenges. Do not think about solutions because I'm going to cover now. Whatever I'm asking is whatever the challenge I explained to you, which we are facing currently, are there any questions associated with it? In Zoom, I don't see anything. Let me check it out here. Okay, I don't see anything over the YouTube also. Great. Okay, where we can. Yeah, the PDF they'll provide it. Yeah, everything will be provided by the upgrade team. Okay, so don't worry. All of them will be provided. Okay. So this is what you all should basically be able to. Yeah, Bitcoin actually it uses again. Bitcoin basically uses a lots of energy. Why it uses a lot of energy is here, the point to be noted in this scenario here is, see, Bitcoin is in a greater demand because its value is in lakhs. Now, say me, somebody comes and says, "I'll give you 1 lakh," and somebody says, "I'll give you 1,000 rupees." Where will you go? You'll go for the one who is giving 1 lakh. Same here also. The value of the Bitcoin is high. That is the reason many people are there to mine the Bitcoin, so that if they get the Bitcoin, they'll get a very good value in the market. That means, in simple lines, there is a very great demand for the Bitcoin. As there is a great demand, there are many miners. When there are many miners, many systems are being present, due to which lot of energy is getting consumed. It's a dot which is interconnected to each other. Okay. Since it consumes so much energy, no, it's not approved by government. Bitcoin mining is not approved by government. Okay. As it consumes a lot of energy, Bitcoin mining is not at all approved by the government. Okay. So, no, as it's impacting environment, who would go and try to implement that? That's not going to make a sense. So it's not approved. Okay. Only Bitcoin mining. Who said it is legal in India? Okay. I'm not saying that it is legal in India. Today, what happened is you can see, you can be able to go ahead and implement this in other parts of the world. Only in India, it is not allowed. And even in India, there is a concept called as the mining pools. If anyone is interested, you can go through it. Okay. Mining pool. Mining pool means you can do the mining in the form of a team rather than doing it individually. This is legal. Mining pool is legal. Mining pool means simply in one line, instead of doing mining individually and consuming a lot of energy, form a team and then you can do mining where you can use less energy. Alternatively, there is a concept called as a mining pool where you can form a team and can be able to do the mining rather than independently doing mining and then trying to deduct a lot of money. The tax divided on cryptocurrency. Yeah, it's a part. It's a part of it. Energy consumption is a part of it. Apart from the energy consumption, there is another part which we call it as here. Like energy consumption is one part, and then it is also having a greater demand. So obviously that is the reason also they are charging a greater amount of tax. Okay, got it. So mining pool is the legal part in India. Okay, just want to give a heads up. Now let's go to the solutions. We'll wrap up solutions and then if there are any questions, again, I'm gonna take it up. Okay. So now what are the different solutions which we can come up with? One is the layer 2 solution. Layer 2 solution means what? Now these are like extra layers built on top of the main blockchain to help you process more transactions. Okay, without changing the main system, you can handle it appropriately. Imagine, think of a restaurant. When it gets too busy, instead of making the kitchen bigger, they add a separate food counter to take out the orders. This way, what will happen? The kitchen can focus on serving the dine-in customers. Okay, while the takeout counter handles the extra demand, in blockchain also we have layer 2 solutions, which will help you process those extra transactions outside your main chain. So, like what we will have is one blockchain, another blockchain. If there are more transactions, then both of them will come into the picture. If it is only limited transactions, then only one blockchain, layer 1 blockchain will be sufficient. So you'll have multiple layers. You can add multiple layers to handle the transactions. If you are having more layers, you can handle more transactions. If there are less transactions, you can have less layer. As I said you, right? When you go to a restaurant, okay, when there are a lot of people, then they'll try to add more tables to it so that everyone can be accommodated. Okay, but they will not say, "Hey, we are not interested onto you, so you can leave." No, nobody will say that. Who will try to lose the business? That is how you can handle your transaction congestion. And then coming to the sharding technique. Okay, coming to another technique called as sharding. So sharding means what? Imagine you go to a supermarket with a long checkout lines. Now to speed the things up, what they do, they divide the store into sections. Like one for groceries, one for electronics, one for clothing. In the same way, each section has its own checkout. So multiple people can pay at the same time instead of everyone waiting in one long time line. So in the blockchain also, sharding is going to split the work into smaller pieces so that you can handle your transactions very quickly. That's what I said you previously also. Sharding means break it. Instead of taking all 100 transactions at a time, try to break into small pieces and then complete your activity. That's it. That is going to be much simpler. That is a sharding technique. As I said you, right? Imagine you go to a supermarket and make everyone stand in one line to pay the bill, then they'll get fed up. Instead, you break it into multiple lines and then ask them to pay the bill. So that people will be happy and you're also distributing the work. That is what we call sharding technique, split and conquer or divide and conquer, we can say. And then coming to cross-chain solution. Now, what is a cross-chain solutions? Cross-chain solution means think of two different bus routes. Okay, think of two different bus routes you have. Okay, and in let me say in a city that don't normally connect it. Okay, there is a new bridge which is built that allows passengers to switch the buses easily. Okay, which can help them reach more places in a much faster way. In the blockchain also, cross-chain solutions are like that bridge which will allow your different blockchains to work together and store information. For an example, you have Bitcoin. Okay, you have Ethereum. These are two different blockchains. You see, Bitcoin and Ethereum here are two different blockchains. Now, when you use a cross chain, then both of them are interconnected to each other and you can handle the things more effectively. So these are some solutions. Like you can have multiple layers to handle the congestion. You can break it or you can divide and conquer so that you can break it and can handle the things more effectively. Cross chain solutions is very much helpful where you can be able to like have multiple blockchains into the system. You can connect them and you can be able to handle the things effectively. That's your cross chain solutions, we would say. Okay, in this way, you have multiple layers of blockchain which you can handle and can be able to overcome the scalability issues. Once I complete energy efficiency, then I will take up again questions. Okay, if there are any questions for solutions, whatever we are discussing right now. Okay, now coming to eco-friendly protocols. As I said you, right, we definitely need an eco-friendly protocol. The reason being, you need a very less amount of energy. We need to look for something where we need less amount of energy. Like one of the example is proof of stake. Proof of stake means what? So proof of stake says you don't need any energy. Okay, you can just come participate and can be able to participate in the mining process and you can complete it off. It like that is what eco-friendly protocol. One of the innovative approaches, proof of stake, where you don't need any control from anyone. It is very less harmful to the environment and you can handle the things effectively. So proof of stake means what? Proof of stake says that you don't need computer, you don't need anything. So for an example, there are 10 people. 10 people will do bidding saying that I have more ethers, I have more ethers. 10 of them will say I have more ethers, but at least system will select only one who has more ethers. Only that person will be given the chance to do the mining. Not everybody. So you're reducing the people. When you're reducing the people, the systems are reducing. When the systems are reducing, the energy consumption also will be less. That is proof of stake. Okay, you are giving a chance only to the one miner based on whosoever is having higher amount, they will only go and do mining. Remaining all of them will sit idle, due to which you are reducing a lot of energy which is being getting misutilized in the process. That is one unique approach which we can use. Comparative analysis. Okay, comparative analysis by comparing with the traditional systems, right? This energy efficient mechanism which we are discussing is actually going to reduce a lot of energy for us. And this is going to reduce the impact even on the environment. So comparatively, when you talk about the Bitcoin, right, where it consumes a lot of energy, here if you see, it is far best where you will see very minimal energy be taken. And that is in return is going to not impact your environment to the maximum extent. Okay. And the future outlook. Future outlook says as the blockchain technology is evolving, right, there is a hope that still we will come up with a more sustainable approach, more energy saving practices, so that everything, whatever we are working is very efficient and eco-friendly. Okay, so the future outlook is we want to come up with such an approach where everything is very economical, very very eco-sensitive, and make sure that it is contributing to the environment but not impacting the environment. That is how the future should look like when we talk about the energy mechanism in the blockchain technology. So now ask me if there are any questions with regards to these two topics. Okay, because slide by slide, we are covering all the questions, right? In that way, we will see if there are any questions, whatever solutions are given for scalability issue and then the energy efficiency. Let me see over the YouTube. Okay. But there are legal apps for trading in Bitcoin. Bitcoin is not illegal in India. Bitcoin mining is being said. Okay, do not get confused with that. Okay, Bitcoin mining is different. Mining is for creating the block. Trading is using the money. Trading means what? Buy, sell, buy, sell. That's it. That is not illegal in India. Bitcoin is legal in India. Bitcoin mining is not legal. To make it very clear over the lines. Okay, hope that it is clear. Yes. Yeah, everything will be shared to you by the team. Okay. Energy. The problem with the Bitcoin is a Bitcoin founder who is Satoshi Nakamoto. That founder is not known to the outside world, and nobody has the guts to change that, because the moment you change anything, right, and if something goes wrong, the entire Bitcoin value will go down. So, due to which they are not trying to do any such things. Okay, they don't want to touch it and try to hamper that entire process. Okay, so it's very energy extensive, and they don't want to go ahead and break that entire process. Yeah, good. Yes, there are two yes who have answered it already. Good job. Okay. Yes, exactly. So divide and conquer, like split it and then proceed further. So yes, again, sharding technique is nothing but, as I said you, right? So you have to divide and conquer. Okay, so what, instead of sending all the 100 transactions into one single place, break it. Just handle first 10 transactions. If you know that you have a transaction congestion issue, then why you take more and then suffer? Take little, complete that little, and then you proceed further. Take little bit at a time and move ahead. That's the point, actually. Now let me come on to the Zoom. At present time, why hard to generate one Bitcoin? Because of the mining. There are a lot of people in the mining process. That is the reason it is difficult to generate the Bitcoin. See, now you're asking, for an example, I'll ask you, why people are not selecting in government job? If I ask you, because there is a lot of competition. For 100 posts, there are crores of people who are writing the examination. Why? Because there is a huge competition. Same approach here also. Why it is hard to generate one Bitcoin is because there are a lot of miners who are there in the process, which is making the life much difficult in the mining process. So be specific. Like, can you explain a little means where? Okay, above one. Okay, fine. So while mining Bitcoin, we are creating new Bitcoin or we are buying it. See, mining is creation of the new Bitcoin. Okay, mining is the process of creating a new Bitcoin. Trading means already there is a Bitcoin you are utilizing. For an example, let's take the best example, RBI. What RBI does? RBI generates the currency and it supplies to banks. From banks, we take a loan or we put a savings money and then we do the money circulation. Same approach here also. Miners here are mining the Bitcoin. That means they're extracting the Bitcoin or they're creating the Bitcoin. Users like you, me, who are interested in cryptocurrencies, we are doing trading based on the Bitcoins which are created by the miner Amandeep. Clear? Is this good clarity to you? Perfect. Okay. Awesome. Great. Okay, then. So we are done almost. So the last thing, again, as I always say you, the future trends. Okay. If you see, right, emerging trends, if you look into, so blockchain is evolving, it is increasing continuously. It's trying to integrate with a lot of technologies like AI, IoT, big data, and it is trying to leverage a lot of great things from the process. Okay, and again, regulatory developments. Today only we discussed everybody. Regulatory developments, if you remember, right? Today we discussed in a detailed way. So you have to follow regulation. If you don't follow regulation, government will not allow you. But again, I'm saying, do not get confused. Bitcoin is legal in India. You can do Bitcoin trading. You can do Ethereum trading, Litecoin trading. Nobody is going to obstruct you. But mining is not allowed. Okay, mining is only allowed in certain countries like Canada, Russia, China, only in those countries. In some part of the Northern America, that's it, but not. Okay, global integration, if you see, global integration means, as I said, blockchain has a very far potentiality. So it can improve even with your traditional systems, and you can use it in wherever you want it. In all the sectors, like we discussed, many of you said banking sector, finance sector, legal sector, healthcare sector, like that, you can use blockchain in whatever sector you want to protect your data and to secure your data as much as you can. So in simple terms, I would say blockchain is evolving with other modern technologies. It's also gaining better regulations and becoming much, much useful across all the industrial sectors which are available in the market as of today. Okay, so with this, I wrap up the session for the today's day 2 bootcamp. Tomorrow we will have the day 3 bootcamp, and we'll be able to further explore some of the use cases, case studies. We will discuss about the blockchain applications, like where and all we can use blockchain in a very detailed way. We will see the case studies and we will be able to move forward. Now, before I wrap up the session for today, are there any more questions which you want to ask? Feel free to let me know so that I can handle those questions for all of you. So today, not like yesterday, okay, today we were able to cover each and every slide, and then I asked you to ask the questions. You all have asked really some good questions, and I was able to answer it. Now, again, at the end, so we have still 5 more minutes. If you have anything specific, feel free to ask. I'll answer all those questions, and we'll close the session for day 2 bootcamp. And again, tomorrow, day 3 bootcamp, we will join and we'll take up the remaining concepts. Yeah, no problem. Thank you for the wonderful feedback. Yeah. Any other example apart from Bitcoin? Ethereum, Litecoin, all of them follow the same approach. Okay. Apart from Bitcoin, you can take your Ethereum, Litecoin also. Those are also same things. Okay. So regulatory framework means, so now you want to go and start a business. So can you start the business in whatever way you want? No, you have to follow the rules which are being provided by the government of India. You need to have a valid GST. You need to register your company, right? So you need to have all of them. So in the same way, when you want to do Bitcoin mining, you have to take permission from the government. Regulatory means government. So the regulatory framework means government policies. Those are. You have to follow the government policy, and if it is appropriate, then you will be given the permission. If not, that is what we call regulatory framework today. Okay. See, how you can use blockchain tech means it depends what project you are doing it. If you are doing a project where you want to have a security aspect, then you will see blockchain will come into the picture. Not everywhere you think that you should be able to fit it. Okay, wherever you believe that security comes into the picture, where you want your product, whatever you're developing, should be protected, it should be secured. Then you can create of thinking smart contracts, and then you can store the product, whatever you're creating as a college project, right? You can take that and can store it into the blockchain directly. So without allowing anybody to tamper that data. That is actually the significance of it. How can we implement blockchain technology in web development? Using Web3. There is a concept called as a Web3. Using Web3, you can be able to integrate that into the web development. Okay. Let me see over the YouTube. Awesome. Yes, we will also go through how we can implement blockchain for having transaction. See, there is no, again, I'm saying you, right? There is no such hands-on activity, Abhinav. It's all like, I'll show you how transactions work, where and all you can see the information, how the blockchain explorer will look like, everything I'll show you. Okay, so you will get an idea tomorrow. Yeah, I invested in crypto and I have already sold it off. So right now, no more investments in crypto. Yes. Okay. Yep. Perfect. Okay, then for last 2 minutes, I'm wrapping it up. So can you give some examples of projects where we can use it? So as I said, you right, you can use it in the if you're taking up the finance application, you can take finance part. You can take supply chain. Okay, you can use it in the college attendance system where you can protect it safely so that nobody can tamper the data. You can put your examination semester papers in the blockchain so that nobody can tamper the data, right? Anything, any project, if you want to pick it up, any sector, Every sector data, you can handle it into blockchain by making it more safe and secure so that nobody can tamper it exactly. Okay. What if the use of mining Bitcoin or any other? The use of mining Bitcoin is to create the Bitcoins. That's it. We are asking what is the use of RBI? If RBI is not there, you cannot generate currencies. In the same way, if mining is not there, you cannot generate or create the Bitcoins. That is the purpose of it actually. Okay. Yeah. How we can access blockchain? Tomorrow I will show you, Amandeep. Not a problem. Okay. Tomorrow we will understand that how we can access the blockchain. Okay. So just wait for today. Tomorrow we'll go ahead and have a look. Best resource for blockchain, you can always have a look into some of the textbooks like Mastering Blockchain by Imran Bashir, okay, or Mastering Bitcoin by Andreas Antonopoulos. Like there are some good, really cool books which you can go through. Okay, perfect. Awesome. I answered all the questions even here in the Zoom and as well as in YouTube also. Great. So again, thank you once again for all of you for your active participation. Okay, if you really have liked the session, so you could please go ahead and then click a simple thumbs up for the YouTube, or maybe even in the like Zoom, in the Zoom also. Thank you so much for your wonderful feedback. Okay, great job, everyone. Thanks for listening very actively and asking questions. I hope I have answered all your questions. And again, tomorrow we will join for our final day blockchain bootcamp and we'll cover the remaining parts. Okay. Thank you once again. Good night. Take care. And we will meet again tomorrow with further topics. Bye bye, everyone.